Can you guys hear me?
Yes, sir.
Now we will talk about the electric field type, right? That, that. Now let us talk about the electric. What is the dipole? We have and there are points at which we calculate the electric, right? And those are axial point, and then the other one is equatorial. What is and ultimately what we will find out. So do you guys remember what we will find out? What we will find out? Yeah, any of you guys remember what would be the value?
K cube by K cube, no, KP by R cube.
Absolutely right. Good. So okay, right. There is that, right? Yes, yeah. Yes. And what about the equity of the equatorial one?
KP by R.
Yeah, both will vary like RQ, right? Both will. So the dipole electric field of the dipole always varies like this. We have studied. So this would be the variation, and you can see that the equatorial one is in the opposite direction of this dipole. Right? That is the minus sign. So this is in the opposite direction as B vector. This is in the direction of B, right? So this is the preliminary idea. This is the goal that we have set up, right? So we already know this goal. Now we have to prove this thing, and this derivation is pretty much important. So yeah, so let us derive. So we have a dipole. Let us first prove that what is the axial. So at an axial point, let us prove that. So this one is a pretty simple one. And yeah, what is it that? So let's say we have these two charges, right? Because dipole is made up of charges which have same magnitude but opposite polarities. This is minus q, this is plus q. And the separation between them is quite small,
2A.
right? So let's so let us say that the separation is this distance is okay. And remember, this is small. So let's pick the center of this. The center would be, so this would be A and A, right? And this is the line of, right? So this is the line of this dipole, right? So if we pick this point or all the point which is lying on this line, except these inside, right? So all the points lying on this line, those are the axial points. So let's say if we pick this point is the axial point, and we take the distance from this end. This is, we always take the distance from this point, right? So this is the distance that we pick. Let's say this distance is this distance is. So at this point, right, we want to calculate the electric field, and we have how many charges? Can you guys tell me how many charges do we have?
Two.
Charges, right? So there would be two contributions. Two contribution, and we have to remember that the electric field we have to always write in superposition principle, right? So the electric field is a vector quantity. It follows the superposition principle, right? So if we write, let's say we want to calculate the electric field at this point, so it will have two contribution as you guys have said. One would be due to this plus Q, the other one would be due to minus Q. So due to this plus Q, what would be the direction of the electric field? Left or right? Yes, guys, what would be the direction? Left or right? At this
Right.
point, right, because this is a positive charge, so therefore the field would be opposite, right? So this is right. And due to this minus Q, where would be the electric field? Right or left? Due to this minus Q at this point, where would be the electric field? Yes, guys. Remember, this is minus. So electric field lines are towards the negative one, or it is away from the negative. What is the direction of electric field lines? Or we can
Towards.
also think it towards, right? So then this would be this side. Clear, guys?
Yes, sir.
Clear. So if we write the net electric field, that would be how much? That would be EQ minus of E minus Q, right? Or if write it in vector form, so if we write E net, so E net is EQ I hat, magnitude is EQ, and then plus E minus Q minus I. So this minus will come here and it will become EQ minus EQ I. So that is why we have written this as minus of this. Clear? Is it clear, guys?
Yes, sir.
Yes, is it clear, guys?
Yes, sir.
Okay, and if we remember the electric field due to a point charge, so this is some Q charge, and let's say this is some right. This is some distance r. We are calculating the electric field at this point. So what would be the electric field at this point? What is the electric field at this point? dq by dt. That is the electric field into a single charge, right? Right, guys?
Sir, wouldn't it be KQP by R square?
AQ, KP by RQ. That's it.
No, sir.
KQ by
KQP by R square.
KQP. Why there would be a P in this? We are calculating. Okay, so let me forget about this. Right. So we have, let us recall this. So let's say we have a source charge in here. Right. We have a source charge Q. And let's say we have this point. which is r distance from it. So if we want to calculate the electric field at this point, what is the electric field at this point? What is the electric?
KQ by R square.
That is what I am writing, right? Let's say so I'll say this. This is the point. This is point, right? This P is denoting that this is some point, right? Clear?
Yes, sir.
Okay. So this is the idea that we have already. Now let us use this idea to calculate that. What would be electric field due to Q charge at this point? At this point, EQ would be 1. So that would be KQ. And the separation between Q and P point. What is the separation, guys? Can you guys identify and tell what is the separation?
R square.
R. So what are the points that we have? So we have this is Q and this is point. So what is this distance? What is this? This is the distance that we have.
R minus A.
R minus A. Right. Absolutely correct. So R minus A and whole square. Correct, guys? Is it correct?
Yes.
Okay, so this is one thing. And then what would be E minus Q? So what is that? E minus Q is what? So that would be right. Again, KQ, because we have already incorporated the direction in negative sign. So whenever we take the direction, then we don't require the negative charge because we have already incorporated the direction. Then what would be this thing? What would be this thing, guys?
R plus A the whole square.
Good. Absolutely right. So you are revising. Good. So then E net. Right. I'm writing here and there. So let me write from here and E net is EQ minus of so how much is it? KQ R minus A whole square minus KQ R plus A. Right. So what is common in here? What is common? We can take KQ common. This is 1 by R minus A whole square. And this is 1 by R plus A whole square. Right. So we see that we can take the LCM R minus A, R plus A. So what would be the LCM? The LCM would be R square minus A square and a whole square. Right.
Yes, sir.
So if we write this thing, or I have eaten up one step, so let me write that step before and then I will write. This is RA minus the whole square, this is RA plus right. And then this would be, because the power is same, so this will go inside and it will become R square minus square. Okay, so this is cancelling. And then we have in the numerator this and R minus A. This is what we are getting, right? So this is KQ and R square minus A square whole square. This is A plus B whole square, so R square plus 2AR plus A square, and then minus of R square
Minus
and
2 RA.
2RA and plus A.
A square.
Good. So then we simplify this thing. This is KQ and this is R square minus A square whole square R square AR AR, what I'm saying. So AR and minus. So we see that this is cancelling, this is cancelling. So what do we have in our? We have KQ and 2AR divided by R square minus K. Now we can put the approximation of our dipole. So we know that this A is very small, this R is very greater than A. So we can ignore this part, right? We can ignore this part and then what we will get. This would be KQ A R divided by R. This R will cancel. And this is 2AQ. What is 2AQ? Can you guys tell me? We have this dipole, right? The separation into charge. What is this thing?
P.
Charge into separation. That is the dipole moment, right? Yes. So 2AQ is P. So this is oh, we had 4, right? So 2AR, 2AR, that is 4AR. And we can take out 2AQ and 2 is here. So this is 2KP by R. That is what we expected, right? And we
Yes,
see,
sir.
yeah, and we are seeing that direction is what? I have in the direction of dipole moment, right? So the dipole moment direction is this, negative to positive. That is the direction of dipole, right? So the net electric field is also in the I hat, which is P direction. So then we can write the axial as Kp divided by. So always remember, right? Always remember. So is it clear, all of you guys? Clear?
Yes, sir.
Yes, sir.
Good. Good. So please note it down, guys. Quickly note it down. And then we'll do the derivation of the equation. Right? Got disconnected. Yeah, Arsenal, whenever you want me to scroll down,
Yes, sir. Done.
then, then
Yes, sir, done.
Then, okay, so this part is also. Now let us so now let us understand. This is this also you have noted, right? This thing you also noted, right? Yes, Archana. Noted.
Yes, sir.
So now let us understand about the equatorial, right? So what would be or what is the equatorial? We have the charge. We have this dipole. And if we, so this is the center of the dipole, right? This is A, this is A, right? And this is the point. And if we draw a perpendicular line on it, right? So if we draw a perpendicular line on it, so that is this a point is called the equator. And we always measure the distance, right? So this is point. We always measure the distance from the center, right? So this is your R. This is your R. And uh, these are the okay, so the- yes, Mariam, you got disconnected. So how much did you know? Yeah. So how much did you?
Yes, sir, over here.
Oh, you have noted it down already.
No, sir, not completely. But I
Oh, yeah.
already have it in our notes.
Oh, you have already done. Yeah. Okay. So then we were talking about the equator, right? So we're talking about the equatorial point. And these are the scenarios, right? So this is A, this is A, and we always measure the distance from this point, right? And this is your theta, right? This is your theta, and if we draw a perpendicular line from it, right? So this is because this is theta, so this would be theta, and this would be again because this is theta, so this would be theta, right? And if we draw, right, so let's say this is, if we extend this line, and if we extend this line, right? So if you look at this thing, this is theta, this would be theta, right? And if this is theta, this is again an right. So this line is again a transversal, and these two are parallel lines. So what would be this angle? What would be this angle, guys? Hmm. So if you have these two parallel lines, if I have this angle as theta, what would be this angle? Oh, yeah. What would be this angle?
Sir, theta.
Yeah, right. So corresponding angles. Yeah. So this is theta, so this would be theta. What would be this angle? Because in the equatorial point, if we have all those theta figured out, then we can write easily derive this thing. What is yes? What is this thing? Again, we see that this is parallel line. This is theta, so this would be theta. Clear, everyone?
Yes, sir.
So why am bothered about these times, right? Because these are very important. So by yeah. So now we have to calculate the electric field, right? But we have to remember another part of the vector, right? So if you have these rectilinear coordinates, right? Let's say this is x-axis, this is y-axis. This is some vector A whose magnitude is A. Let's say this theta is this is angle is theta. Then what would be this thing? What would be this thing? What would be this part? This is very important. What is that? Yes, what is this thing? So this is with the theta component. So this is a cos theta. This is with the y component. So this is a sin theta. This is the resolution of vector. Yes, guys, can you guys hear me? Hello.
Yes, sir.
Yeah. So this is resolution of vectors, right? For the component with a theta angle, a cos theta, the component without the perpendicular to that, that is the sin theta. So we will use this analogy, right? We will use this analogy. Okay, let us get back to this thing. So we have a negative charge. We want to calculate the electric field at this point. So what would be the direction away from it towards that point? Towards minus q, away from minus q. What would be the electric field direction? Yes. What would be electric field direction? Towards minus q, away from minus q. Yes. You guys see something? This we have discussed, right? So what would be the direction? This is negative, so
Sir, your voice seems stuck, sir.
that would be attractive, so it would be towards
Yes, sir.
pain.
Can you hear me?
Yes, my voice is like, yeah, I can hear you. Yeah, I can hear you. Can you hear me? Uh, can you guys hear me properly? Yes, Arsalan, I can hear you. But can you guys hear me? Mariam, can you hear me? Yes, what is happening?
Yes, sir. I can hear you.
Yeah.
Yes, sir.
So can you hear me?
Yes, sir. I can hear you now, sir.
Yeah. So what I was saying that due to this minus q, the
Hmm.
electric field would be towards its side.
Yes, sir.
And due to plus Q, what would
Elec-
be the electric field?
Electric field B will be going away from Q, sir.
So that would be in this direction.
Yes, sir.
Good. So we have this plus Q, this is minus Q. So now what we can see that the electric field, right? Because this is not in some X and Y direction. These are some arbitrary direction. So we have to write it in X and Y components, right? So this is EQ, this is E minus Q, right? Okay, so we'll talk about the magnitude later, but this is the angle theta, right? This is the angle theta, and this is the vector, and this is y-axis, right? This is y, this is x. So what would be this component? Can you guys tell me what would be this component?
Yes, sir.
Yes. What would be this component? This is this is EQ cos theta, right? And then this is y component. This is EQ sin theta. Let me write it with a different colors. This is uh, this EQ sin theta. Let us talk about the components of the other one. So E minus Q. This is theta. So this would be how much? Again, E minus Q. And what would be the component, sine or cos, for this minus Q1? What would be the component? This component would be how much? So again, this is with theta, so this would be cos theta. And these are the axes, so this would be EQ E minus Q sine theta. And you guys can see that EQ sine theta is this way, E minus Q sine theta is this way. Both are equal in magnitude. So magnitude of EQ that is equal to E minus Q. Why? Because separation is because separation and magnitude both are same. Both are same. Direction is opposite. So only direction is opposite, but magnitude is equal, right? So how can we figure that out? Because what is the separation between this point and this point? What is the separation? And what is the separation between this point and this point? Can you guys tell me what is the separation between this point and this point? What is the separation? So remember, this is R, this is A. So this is your picture. This is R, this is A. So this is root of
R
R
plus A,
square.
R square plus A square.
Similar situation in here. Similar situation, exactly similar. You have A, you have R. So this would be again root of R square plus A. So that is why both the separation from this point to this point, from this point to this point. Separation is same, magnitude of charge, that is also same. So if you have kq by r square, this is same, right? That is equal to kq by r square. This is also same. So electric field would be, right, let me write it as x, x. So electric field of minus q, that is equal to plus. Magnetic field will cancel this part out. Only thing that is remaining is what? So then the surviving electric field, surviving or uncancelled electric field. What is that? What would be that? Can you guys tell? In the meanwhile, I will say, you guys look at the diagrams and tell me what is the electric field which is net and which is not getting cancelled. Look at the diagram. Yes. What is the diagram, guys? Oh, what is E net? You see EQ cos theta, both in the same direction. So they will add up. So this would be 2 EQ cos theta because both magnitude is same. So I can write it as E as well. Right. So let me write it as so I can write it as 2E cos theta. Right, guys? This is E cos theta. This is E cos theta. So 2E cos theta. Clear?
Yes, sir.
Good. So now E net is how much? 2. E is how much? E is simply E minus Q, or we can calculate EQ. That is KQ by what? KQ by what? Yes, please tell me. Separation square. So what is the separation square?
Root of r square plus a square.
The whole square. Right, good. So this is the separation and then square. So this is simply KQ by R square plus A square. Right, guys? Okay. So this is KQ by R square plus A square. Now, what is the value of cos theta, right? So this is a theta, and we already know. What do we already know? That what would be cos theta from this triangle? What would be cos theta from this triangle? Can you guys tell me? Hmm. What is the cos theta from this triangle? What is base? Base is A.
A
Hypotenuse is
by
what?
root of r square plus a square.
Right. Yes. So this is good. So this is your cos theta. We can put this cos theta in here. This is A by, let me write it in powers. So in powers, this is how. So you guys see that this is same thing. Base is same. This is power 1. This is power half. So 1 plus half. That is how much? 1 plus half is 3 by 2. Right. 1 plus half. So that is 3 by 2. And again, if we write R greater than A, not equal to, very much greater than A. This part will cancel. And this is if we write it into A cube, right? Divided by R square power 3 by 2. So this will cancel. And this is again Kp by R cube. So this is the magnitude, right? So E net, which is magnitude, and you guys can tell me the direction also. So the direction of dipole moment is this, from negative to positive. This is dipole moment. What is the direction of electric field that we are getting? Left hand side, right? So that is minus of P hat. So E equatorial vector, that would be how much? Minus of K P vector divided by R. So is this thing clear, guys? Is it clear?
Yes, sir.
These two derivations are very, yeah, these two derivations are very. Okay, so you guys please note it down, and then we'll talk about uh, Gauss law, electric flux, and I can also talk about the torque experienced by the electric current. Quickly note it down, guys. Quickly note it down, and if you guys have any question, please tell me. Yeah, when you guys want me to scroll down the screen. So when you are able to make this diagram, then all your answer or calculation will be. So this diagram is the most important. You guys want me to scroll down the screen?
Yes, sir. I'm done.
Then, okay, so then now let us talk about. So this is the Lect. Right. Now let us talk about the force experienced by a charge in an external electric field. So what is the force? Right. So if you have, let's say, electric field, and this is a uniform electric field, right? And you put some charge in here. So if this is positive, right? If this is positive, so force would be in this direction. That is Q. So this is pure force. And if you have a negative charge, minus Q, so force would be in this direction, and that would be minus Q. So this is the force, right? So F would be for positive charge, this is QE, and for negative charge, this is minus Q. This is the important thing to remember. And then, if we place a dipole, right? If we place a dipole in the uniform electric field, then what happens? So if we have a dipole, right? So this is the negative charge. Let's say this is negative one and this one, and let's write it with some. Right? Let's write it. With this is plus and this angle is theta, right? So this is your electric field, and this is your dipole. And the direction, so this is the direction of what? Dipole moment. So P and E are making an angle, right? So then we write the torque on this dipole. I will not derive this thing, right? I will not derive this thing. I will directly use that because derivation we have done, and you guys can check that. So what is the torque on this dipole? You guys remember what is the torque? Yes, what is the torque on this dipole? This is P cross E, right? And then what is the magnitude? This is PE sine theta. This is the torque in an uniform electric field on a dipole, right? And there were three cases. So the first case was theta equals to 90. So for that case, torque was maximum. And then we have theta equals to 0 degree. So this is torque is 0. And then this is stable equilibrium. And the third case was theta was 180, and again torque was 0. So for both cases, torque is 0. But this was unstable equilibrium. Right? From graph, how can we say stable and unstable? So let's say you have these two surfaces, right? and these are some objects. So if you take this object, if you move this object in here, right? So again it will roll back and it will reach this position. So this kind of equilibrium is called as stable. And let's say if you have object, so if you push this object in here, so it will go down. So this thing is called unstable equilibrium. So is it clear, guys? Is it clear?
Yes.
Yeah. So quickly note it down, and we'll stop here, right? And the next class. So this chapter is almost here, and we'll talk about the next potential chapter in the next class. Okay. You guys also on your part those derivations and revise them, right? So these are important ones.